Water is found almost everywhere on Earth, but you may never find it in the pure form. It always will have some substance dissolved in it. Drinking water is a solution, a very dilute solution of different mineral salts. Seawater, as is well known, is a solution of sodium chloride and many other substances including oxygen. Water dissolves a large variety of substances in it. Some, like sugar or common salt, dissolve readily and completely. Some, like chalk, only sparingly. Some substances dissolve to a very, very small extent. So much so, we can say they do not dissolve in water at all. Let us dissolve this colored substance in water. Notice that stirring helps in dissolving it faster. An increase in temperature also affects dissolution. This also means that at a given temperature, there is a definite amount of substance that can dissolve in a given amount of solvent. We define that as the solubility of that substance, which means that no more than 35.98 grams of common salt can dissolve in 100 milliliter of water at 20 degrees centigrade. Plotting the amount of solute dissolved on the y-axis and the temperature on the x-axis, we obtain the solubility curve. This graph clearly shows that a hot liquid has a greater capacity for holding the solid in solution. However, there are a few compounds such as calcium chromate, calcium sulfate, and calcium hydroxide whose solubility decreases with an increase in temperature. When we have dissolved the maximum possible amount of solute at a given temperature, we obtain a saturated solution. Obviously, on cooling, the excess solute precipitates out. If it does not, we have a situation where the solution holds more solute than its solubility permits. We then have a supersaturated solution. Honey is an excellent example of a supersaturated solution of sugars in water. Sodium acetate and sodium thiosulfate are notable examples of compounds that readily form supersaturated solutions. In the case of a gas dissolved in a liquid, reduction in temperature increases its solubility. The more the drink is chilled, the fizzier it will be. Now, can you guess why tropical fish in an aquarium are more likely to need air bubbles? In a true solution, the solute is completely dissociated into its atoms, molecules, or ions and homogeneously mixed with the solvent, and cannot be separated by a process like filtration. When we try dissolving chalk in water, we observe that the particles get distributed in water, leading to a cloudy mixture called a suspension. In comparison to solutions, suspensions contain much larger particles. Suspensions can be filtered out. Chalk particles may be too small for you to see, but they are big enough to be trapped by filter paper. When alum is added to water, aluminium hydroxide is formed. When the precipitate settles down, it carries down bacteria, mud, and other impurities, clearing the turbidity. Blood is a life-giving solution of gas, nutrients, and the waste products of metabolism. At the same time, blood is a suspension, a liquid throughout which large particles such as red and white blood cells are distributed. Ethanol completely dissolves in water. So, ethanol and water are said to be miscible. But if you add petrol to water, the two liquids will not mix. They are said to be immiscible. The density of petrol being less, it floats on water. Some substances like metal sodium react with water, and hence the solution formed is that of its hydroxide. On evaporation of this solution, we get white sodium hydroxide. That is why sodium is kept under kerosene, out of contact with atmospheric water. What exactly happens at the atomic scale when a substance dissolves? Water, as we have learnt, is a bipolar molecule with a partially negative oxygen and partially positive hydrogens. So, when a solute with positive or negative parts is dissolved in water, like the positive sodium ions and the negative chloride ions in the case of common salt, the ions are surrounded by water molecules oriented like this. The water molecules are said to form hydrogen bonds with the ions. The shell of water around the ion, known as the hydration shell, prevents the ions from coming together. In the case of sugar, the sucrose molecule contains polar hydroxyl groups which form hydrogen bonds with the water molecule. Oil and water do not mix. And therefore, an oil film spreads on the water. Non-polar oil, however, dissolves in a non, such as carbon tetrachloride or hexane. Many covalent molecules, such as oils and greases, need non-polar or organic solvents. A substance like iodine is insoluble in water. But dissolves in a solution of potassium iodide. Now we add carbon tetrachloride. Observe that carbon tetrachloride does not mix with water. Also observe that iodine dissolves in carbon tetrachloride. The solubility of iodine in carbon tetrachloride is more than in potassium iodide. This helps us separate iodine from the solution. We use a separating funnel for the purpose. This is iodine dissolved in alcohol. Tincture of iodine used commonly as a medicine. Some types of glue are dissolved in an organic solvent like acetone. When the solvent evaporates and the glue dries, it leaves behind a sticky solid that binds the surfaces together. When a solution is heated and the solvent evaporates, the solute is left behind. We get a colorless salt. What happened to the bluish color? Now, let us add a few drops of water. The color is regained. The substance is blue vitriol or copper sulfate pentahydrate, a commonly used insecticide. In the case of copper sulfate, 4 water molecules are hydrogen bonded to the dye-positive copper ion and 1 water molecule hydrogen bonded to the dye-negative sulfate ion. When we evaporate the solvent, all the water molecules, including those involved in hydration, are lost. The colorless salt we obtain is anhydrous copper sulfate. When we add a few drops of water, the water of hydration is regained and we have copper sulfate pentahydrate. There are many metallic salts which show such behavior. They are known as hydrates and the water molecules associated with it are called water of crystallization. When hydrates are heated above a specific temperature, they either become colorless or change color like this. This is sodium thiosulfate pentahydrate, used as a developer in photography. Borax is a decahydrate, 10 water molecules associated with each of its molecules. And alum is dodecahydrate. It has 12 water molecules associated with it. The opposite behavior is deliquescence. These salts absorb the moisture in the air. Calcium chloride, a drying agent, is an example of a deliquescent hydrate. Left in a watch glass, it will turn into CaCl2, 2H2O, and then into CaCl2, 4H2O, followed by CaCl2, 6H2O, and eventually into a pool of liquid which is a solution of the salt. We began with water and found that many substances, solids, liquids and gases dissolve in it. We also discovered that different substances dissolve to different extents and some do not dissolve at all. Factors like temperature affect the solubility. A solute and a solvent together form a solution. We define a solution as a homogeneous mixture of the solute and solvent particles. The water molecule is a polar molecule with the hydrogen ends having a partial positive charge and the oxygen end having a partial negative charge. This helps the water molecule to surround the ions or polar particles of the solute and form hydrogen bonds. We cannot separate the solute particles from a solution through processes like filtration. We get back the solute by evaporating out the solvent. Like water, a number of organic liquids are used as solvents. Hexane, and carbon tetrachloride are some examples. Of all the solvents we encounter, water appears to dissolve the maximum number of substances. Water, therefore, is so far the best candidate for the title universal solvent. But it is this very same property which has got water into trouble. Rarely will you find a pure water source anywhere. Increasingly, you will find polluted water sources, some of them beyond safe use. Solutions play a significant role in our lives, so much so that life itself would not exist without this facet of nature.